Okay, guys, quiet, please. All right, we're on page 52. Today we're going to talk about acids and bases, and then we're going to squeeze in strong acids and bases. Since I was gone yesterday, you guys are a little bit behind, but we're going to get caught up today. So be prepared for a roller coaster ride of fun today with all of our notes. Okay. All right, guys. So what you guys should be able to come out of this is, if I were to give you guys a list of formulas, you guys could name which ones are acids, which ones are bases, which ones are neither acids or bases, and which ones could be both an acid or a base. Okay? What's that?
Do you have any examples?
We don't really have examples, no. Okay, so we're just going raw, like straight on 52. Raw. Okay. What's that? Raw.
Sometimes I get my 52s mixed up. Is that okay?
I know, I get 7s and 4s mixed up. I don't know what you want.
No, like I put acids on 52.
That's okay.
Okay.
We'll do bases on 52.
Good.
Okay.
Well.
Alright, so 52, we're going to talk about acids. So what we're going to look at when we look at each acids and bases is we're going to look at kind of in general what is a base, okay? Like the little kid definition of what a base is. We're going to talk about some uses that you guys see with acids and bases. And then we'll talk about in chemistry, what does that mean if we talk about an acid or base? How do you guys define that? Okay? So the first one that you guys need to learn is acid comes from the Latin word meaning sharp or sour. Okay? Those acids that, what?
It didn't get Latin. Oh, there. Oh, almost.
Okay. So like those things that you guys would be able to taste that aren't like corrosive acids and bad acids, you guys would be able to taste those and they'd have a sour taste. Obviously things like sulfuric acid you're not going to be dropping on your tongue because that's going to burn.
Why not?
So like lemon.
Citric acid burns.
Lemon it's got citric acid, okay? Ascorbic acid as well. Vitamin C has those kinds of things, and we'll talk about a couple of those different ones. Vinegar is an acid. So that's why it has that sour taste. Even if you guys, like, hydrochloric acid is found naturally in your stomach, okay? Your stomach has a special lining that handles the acidity of it. Otherwise, it would eat itself. So you guys can get ulcers from that lining being not produced well, and you'll start eating away at your stomach lining. And you basically get ulcers, which are open sores.
Doesn't it like replace itself like every week or something like that?
It always is. It's like a mucus, so it's constantly secreting this mucus every time your hydrochloric acid is secreted. But if you guys vomit, like you get that sour taste in your mouth, that's that hydrochloric acid.
Can we try that out?
No, thank you. Hey guys, I need you to focus now.
That's badass.
Okay. Some properties you guys would see is that it has that sour taste like we were just talking about. Most acids react with metals, and that has to do with your guys' reactivity series of metals, if you guys remember back from single replacement reactions. Okay, if certain metals are more reactive than the hydrogen, then it'll kick the hydrogen off the acid. Okay, so it'll react with it. Most of your acids will react with it. Okay, it conducts electricity. What word or vocab word do we use to describe a chemical that conducts electricity? It is not a conductor.
It's
Ionic.
Ionic are this type of thing. They can conduct electricity. What's it called if it can?
Anion.
I even underlined part of it.
Electricity.
Electric.
Electric.
Conductive.
Electrolyte. Good. I thought I heard it in there.
No.
Okay, an electrolyte has the ability to conduct electricity. Acids also have a low pH value, so anywhere from 0, they don't quite go to 0. But just
Excuse the interruption. At this time, will you please release the boys and girls soccer team?
okay.
Thanks.
Low
And good
pH
luck
value
today.
from about 0 to 6. Okay. The video will be online for you, Vicente. And then most are corrosive, meaning that if you spill acid on your hand or on a table or something, it's going to start eating away at that. Acids are pretty good at that. Okay, if you guys get it on your skin, you're going to feel it pretty quickly. Especially the stronger, like the higher concentration it is, the stronger it'll be. Okay, so that'll make a big difference as well. Just a heads up before you leave, Vicente, there's a quiz tomorrow in class over molarity and dilution. So if you were gone Friday for that dilution section, you guys need to watch that video. I fixed the one on my link if that one wasn't working for you guys yesterday. I don't know if any of you guys even tried to watch it like you were supposed to.
I watched on my phone.
But if not, you guys can just go to YouTube and search that as well. You guys can type in Crofutt and dilutions.
Is that a 0 and a 6?
That's 0 to 6, yeah. Okay. All right, some uses that you guys see is vinegar. You guys see vinegar a lot is acetic acid. Ascorbic acid is not vitamin C, but it's associated with that sour taste that you guys get with vitamin C. Sulfuric acid is used in a lot of industrial type industries like making steel, making paint, making plastic. fertilizer plants use a lot of sulfuric acid to make their fertilizer, steel, stuff like that. Hydrochloric acid we find most common in our stomach. Citric acid is a sour taste that you guys get in citrus. Also, like candy companies will use that citric acid, like Sour Patch Kids and stuff. They have a lot of citric acid, like all that sugar and stuff that's left over. A lot of that citric acid. If you eat too much of it, yeah, it like kind of buzzes your tongue. I don't know how to describe it, like numbs your tongue. And then of course, like battery acid is probably your strongest type of acid. It's the one that's closest to zero. Okay, so those are some general uses. That's why I advise you guys not to also drink paint. Or eat fertilizer.
What kind of acid's in bleach?
Hypochloric.
Is that deadly?
Hypochloric. What?
Is hypochloric acid deadly?
Yes, you can't drink bleach.
Hypo. Water.
You can't drink water.
Is it hypochloric? I think it's hypochloric.
gas?
Okay, guys. In chemistry, this is the part you guys need to know, though. Quiet, please. This is the part you guys need to know. Okay. What we need to know about acids and bases for chemistry is they generally increase the proton concentration in a solution. What we refer to as a proton is our H+ ion. Okay? So when we talked about ionic compounds a long time ago, we looked at, it has a metal and a nonmetal. We find metals on the left side of the periodic table. Our nonmetals are on the right side of our periodic table. One kind of exception to that was hydrogen. Okay? We know hydrogen is a gas, therefore we know it's a nonmetal. But it is listed on the left-hand side with the rest of the metals. Why is that? Well, when we use it in an ionic compound, it's an acid. So if it's an ionic compound and it starts with hydrogen, it's an acid or a base. It's a type of ionic compound. Okay? So if it starts with an H, it's an acid. Okay? When we look at ionic compounds, we know they're formed from ions. So we've either given and taken electrons to form ions, and then those two charges attract. With hydrogen, a normal hydrogen atom has one proton, one neutron, and one electron. Okay? But when we form an ion with it, we lose the one electron. So really all that we have left over is a proton and a neutron. Well, a neutron has a neutral charge, so it really doesn't matter. So what we're donating when we throw that hydrogen at the beginning is one proton. Okay? So that's why it's referred to as it increases the proton concentration. It's also referred to as a proton donor, meaning it starts with the H+ ion. Okay, the hydrogen ion. Okay, so generally increase the proton concentration in the solution, meaning it starts with the hydrogen. So when we take like hydrochloric acid, it's HCl, starts with hydrogen. We throw it in water, it's going to break into H+ and Cl-. So we've added a proton in that H+. And that's where we get acids and bases. And we'll talk a little bit more about like where we calculate the numbers from and why like pH is written little p big H. Okay, it has to do with hydrogens. Okay, some different acids you guys need to know about is hydrochloric acid, HCl. Sulfuric acid, H2SO4. Nitric acid, this is the acid that we used to dissolve our copper when we did that copper recovery lab. So that's HNO3. H3PO4 has 3 hydrogens we can donate, or 3 protons, so that's phosphoric acid. And what about water? What do you guys think about water?
Isn't it just neutral though? Like, isn't it like on the low end of the scale?
It could be both.
It could be both. So this is what, and we'll talk a little bit more about neutralization here in like a page or two. But water can be both. Remember when we balanced equations, how on one side we had a hydroxide, on the other side you guys had a water? You guys were able to rewrite it as HOH. Okay? It starts with an H. So acid can act, or water can act as an acid. It can also act as a base, which we'll learn about here in a second. Okay? And then together they cancel each other out, so that's why water is neutral. Okay? And like I said, we'll talk a little bit more about that here. So water can be an acid, water can be a base. Is it a strong acid? No. Okay, obviously not. Okay, the last little piece you need to know about this is all acids and bases are ionic. Okay, the metal in the ionic compound is your hydrogen ion. Yeah, remember we write our metal first, metal then non-metal? Our hydrogen's listed first. So it's our metal. It's the only time it acts like a metal. Other than that, it's a gas and it's a non-metal. Does that make sense? Okay. All right, next page, we're going to do bases. Page 53, or if you're Jocelyn, who can't tell the difference between 2 and 3, it's going to be page 52, which is all the same to her because she can't tell the difference. Okay, bases. Have you guys ever heard of the word alkali? Yeah?
Yeah.
Okay, it's often used to describe alkali things, which in this case, what you guys need to know about it is bases. Okay, so you guys often hear bases described as alkali. They conduct electricity. So just like they're ionic compounds, and we know that all ionic compounds are electrolytes if they conduct electricity. Bases are no different. Okay, they have a slippery feeling. So soap, for instance, have you guys ever taken just like Dawn dish soap and rubbed it between your fingers?
No.
Dawn has some weak alkali or bases in it, so a little bit of that is weak, and that's why it makes it slippery. Okay, Drano. If any of you guys have accidentally got like Drano or oven cleaner on your fingers, you get that slippery feeling. Also, that's because that Drano is really, really strong and it's eating away all the proteins in your fingers and in your skin. A couple of years ago, I had a kid making me, it was Dave Kelly, was making me a solution of sodium hydroxide, and the sodium hydroxide that I get is in pellet form. So it's like the most concentrated sodium hydroxide you can have, not to mention sodium hydroxide is one of the strongest bases there is, too. And even the amount of water that was in his fingertips, like in his hands, which some of you guys have really dry hands, you'd be like, I have literally no water. There's enough water on his fingertips to start reacting with that sodium hydroxide and eating away his skin. He's like, my fingers feel funny. I'm like, that's because your skin is getting dissolved. Yeah, wash your hands. They do not react well with metals. Okay, so one thing that's great about that is if we look at acids or bases, acids react really well with metals, whereas bases don't. Okay, that's why you guys see bases used as cleaning products. So Drano, like I was talking about, sodium hydroxide is basically all that makes up Drano. If you guys were to pour, you have a clog in your drain, and you guys were to pour acid down your drain, what's going to happen?
Your drain's going to go away.
Your drain's going to go away. Not only is the clog going to get eaten up, but the metal in your pipes are going to start getting eaten away at too, depending on what your pipes are made out of. Okay? But the thing that's great about this and why we use stuff like sodium hydroxide and potassium hydroxide for Drano is that it's not going to eat away at your pipes, but it will break down all the proteins and crap in your clogs. What's up?
What if your pipe was copper?
You'd have to look at the reactivity, activity series of metals. But even so, the bases won't act with that copper.
For acids.
You'd have to look at that. I can't remember where copper is versus hydrogen. So if copper is more reactive, then it'll replace the hydrogen. They'll react. Yeah. They have a bitter or chalky taste. How many of you guys ever had Tums or Rolaids before?
Oh, yeah.
Okay, those are weak bases. Okay, they have that chalky taste to them. So you guys have all tasted a base at some point. Or if your mom makes you wash out your mouth with soap. How many of you guys ever had to do that?
I did it by
It doesn't
choice
taste
after
good, right? It has that bitter taste.
Too.
That's because it's a base. High pH, generally on the pH scale, it runs from 8 to 14. 7 is your neutral. And then they can be corrosive. Like the other day I spilled sodium hydroxide on myself, and it definitely was a little corrosive. I could feel it burn because it was really strong.
Oh, jeez.
But it was, like I said, got that slippery feeling, so I knew it was still there when I could still feel my skin slipping away.
Oof.
But it didn't corrode too fast. Like, I got it on my coat and didn't realize I had it on my coat. The next morning I'm driving to school, I'm like, what is the white stuff all over my coat? Realized that it was that sodium hydroxide because it splashed all over me. So it didn't, corrode through my coat, which was great, but it still isn't good to have on there. Now I'm getting a little itchy from, where I spilled it. Paranoia. Okay. Uses. Baking soda is a base. Okay, it's a very weak base. Same kind of stuff you guys use to mix with vinegar, which is an acid to make sweet volcanoes when you're in 3rd grade, or when you're an adult too, because you do fun things like that. Ammonia is a weak base. It's a glass cleaner. It's the same kind of stuff that I was dropping in when we did the dry ice. That was turning it the blue colors and stuff. Drano and oven cleaners are both very strong. Blood is slightly basic. Blood has a pH of about 8-ish. Okay. Soaps or cleaners are usually pretty weak, and acids are usually pretty weak. Again, if they were strong, we wouldn't be popping them in our mouths. Okay, that seems like the impractical thing to do with something that's a strong base. If you guys don't get all these, that's not a big deal. Okay. Yes. Got it? All right, so your chemistry definition. Just FYI for future, if any of you guys intend to take any chemistry in the future, there's 3 different types of acids and bases that you learn about. These are what we call, like my definition for you guys, it starts with a H+, or in this case ends in a hydroxide and OH. Those are what we call Arrhenius acids and bases. When you guys take upper level chem courses, like if you were to take advanced chem, you guys would learn about Bronsted and Lowry bases, which would be more like ammonia and stuff, things that don't necessarily have an OH but are still basic. Okay, and then when you're like really complex, and I still don't quite understand this, there's Lewis acids and bases, which are really complicated. Okay, but at any rate, you guys are just learning about the most simple kind. So an acid starts with a hydrogen, a base has an OH in it. Okay, so generally increases the hydroxide ions concentration in a solution. So if you guys remember back to polyatomic ions, hydroxide right there, OH minus. Okay, so it has some kind of metal, and then it has hydroxide for the non-metal. And that, like I said, that's not all the case and not all the kinds that we learn about. We call them proton acceptors because that hydroxide will steal a H+ and make water. So it accepts a proton to make water. And OH plus an H makes HOH. Some common examples that you guys see is, like I've just talked about, is sodium hydroxide. You guys see that OH there? There's that OH. Okay, potassium hydroxide, KOH. And then again, water. If we rewrite water, it's HOH. You guys see that OH in there. Okay, so that's also can be a base. And we'll talk a little bit more about this on our last page of notes. Got that? Ivan? Good? Alright, next page. We're on page 55? 54. We're going to talk about strong acids and bases. This is going to drive me nuts because it's randomly capitalized. Whoa. It's a strong word, kids. Alright. The first thing we're going to talk about before we get into strong acids and bases is this concept called neutralization. So neutralization is the same kind of thing. Has anyone in here spilled acid on themselves? And I if you guys spill this on yourself, let me know. I need to fix it. Okay. What did I put on it, Ty? Do you remember?
Baking soda.
Baking soda. Okay. So he had an acid. It's going to keep burning his skin, even if he adds water to it to rinse it off. Unless it gets all of that acid rinsed off, whatever's left over is basically just diluted. But it's still an acid, and it's still going to eat away at your skin. So I took baking soda, which is a base, and added it to it. That neutralizes the reaction. Okay? And depending on the strengths, too, that makes a big difference. But at any rate, you can use a base to neutralize an acid. That's the same kind of concept with water. You have an acid part of it, and you have a basic part of it. It kind of neutralizes itself. That's why water has a pH of 7. Okay? So neutralization reaction is anytime you guys take a strong acid and a strong base, react them, and then you guys always form a salt in water. Not necessarily table salt. Okay? A salt is basically any of your alkali earth metals or your alkali metals, the first 2 columns of your periodic table. Those are the metals you use, and then any type of halogen. So like fluorine, chlorine, bromine, iodine. Put those together, you formed a type of salt. So like sea salt is magnesium chloride. Okay? Table salt, sodium chloride. All of those are types of salt though. Okay, so here's some 2 examples of reactions you guys can use. If you guys were to take stomach acid and mix that with sodium hydroxide, okay, stomach acid, hydrochloric acid is a strong acid, sodium hydroxide is a strong base, they're going to form water, HOH, and NaCl. This is just a double replacement reaction where you guys are taking the positive hydrogen and switching it with the positive sodium. Okay, so you'd form HOH and NaCl. Easy enough?
Mhm.
Okay. Another type of reaction that you guys might see an example of is calcium hydroxide, which is basically like chalk. And sodium hydrochloric acid. Again, you're going to form water, and you're going to form a salt, which is calcium chloride. Okay, these can happen, like I said, with, they don't happen as efficiently, but they can happen with, why is that blinking red? Is it still filming, Liv?
Yeah, hold on, sometimes just like,
Okay.
Yeah.
It's just blinking red at me, which is weird. I don't know if it's dying.
The
maybe.
battery's about dead.
Oh, God. Okay, let's get it done, guys. My battery's done.
Yes.
All right. Strong acids and bases. They completely dissociate in water, meaning that an ionic compound is made of two ions. When we toss those in water, they break into the two ions. There's no ions left in a compound. Okay, they're all by themselves. Okay, they're going to be obviously more reactive than weak. Well, duh. Okay, things like antacids, which are magnesium hydroxide. If those were strong, they would like eat away at your mouth as you're popping Tums. Okay, we want things that are reactive in certain cases, but we also want weak things too, like vinegar. We can eat that. Lemon juice. We can eat that. Okay, and then all strong acids and bases are strong electrolytes, meaning that if we have an acid or a base that's strong and we throw it under that light bulb, it's going to really light that light bulb up. It's going to be super bright. Okay, does that mean that all acids and bases, all electrolytes are acids and bases? No, right? We talked way back when we talked about ionic compounds. Ionic compounds are electrolytes. So, for instance, sodium chloride, that's a strong electrolyte. It really lights that light bulb up, but it's neither an acid nor a base. So don't get those two confused. All strong acids and bases are strong electrolytes, but not all electrolytes are acids and bases. Okay, right below this, for the rest of the page, we're just going to do a little T-chart. A little T-chart. So in one column, you guys are going to have strong acids. And in the other column, we're going to have strong bases. I think it just died.
No, it's still going.
Stop blinking at me. Huh?
I think it's closed. It's still going.
It's not blinking at me anymore, though. All right. We're going to come back to this little T-chart. I'm just going to read these to you guys, but I'll get these recorded in a second. Does someone want to just run in? Oh, no, I don't. All right, these are just an example of some. We'll get these written down here in a second. So strong acids would be like hydrochloric acid, hydrobromic, hydroiodic, chloric, perchloric, nitric, and sulfuric. Okay, strong bases. You guys are going to take, actually, I think it's going to stop there. Is it still going? Oh, it's red here too. So I don't think it's recording anymore. I don't know.
I don't know, the things.
Let me know if that changes. All right,
The
strong
camera's still going.
acids. Once you guys, if you guys look at your periodic table, your very first column of metals is called your alkali metals. Any of those mixed with hydroxide is going to be a strong base. So an alkali, well, again, don't write this down. We'll get them here in a second. Like lithium hydroxide, sodium hydroxide, potassium hydroxide, they're all strong bases. If you guys look at your second column, those are your alkali earth metals. Only the heavier ones of those are going to be strong acids and bases. So they consider heavy as calcium and below. So calcium hydroxide, strontium hydroxide, and barium hydroxide are all strong metals, okay, or strong bases. Magnesium hydroxide, for instance, isn't quite as heavy, so it's not a strong one. It's going to be a weak one. So that's what you guys see, like Tums and stuff. Okay, last little page. Weak acids and bases. Weak acids and bases are going to be kind of opposite. They only partially dissociate in water, meaning that they only partially break into their ions. Okay, some of them will stay in a compound form. Others will break into ionic. Is it still going, Lib? Mm-hmm. Maybe the swivel part's just broken on it, or not broken.
Can you go back?
That might make sense. What's up?
Can you go back up a little bit?
That's all there was. What's the title? I'm okay if the swivel doesn't follow me. That's a good thing. Maybe it's just that part that died. But my iPad should be fine, right?
Yeah, it should be.
What about the sound, though?
I don't know.
Oh, they got pictures.
Yeah. So,
This one will be, because this one's right here.
I'm not sure how you measure that.
Someone can film it if it goes wrong.
We'll see. All right, so they only partially dissociate with water. They're going to be weak electrolytes. They'll still be electrolytes. They'll still light up our light bulb, but only dimly. Okay, so like vinegar will light it up, but vinegar is pretty weak. Okay, your little T-chart. You guys can just, there's not much for this T-chart. Weak acids, as acetic acid, which is vinegar. Okay, that's the only one I really list for you guys. Weak bases, ammonia doesn't follow our hydroxide rule, but you guys still should know it. Magnesium hydroxide, beryllium hydroxide, magnesium hydroxide would be like antacids. Okay, again, we don't want those to be strong.
So how come the NH3 is base because it's not an OH?
It's, you know how I talked about there's 3 different types of acids and bases. We learned the simplest.
Oh, yeah.
It's one of the more complicated ones, but I want you guys to recognize it as a base, so that's why I listed it up there. Because you guys don't recognize it because it doesn't have OH in it. But it's a base because it'll form ammonium, NH4+, so it'll accept a proton to form NH4+. Okay. So last of the blurb of this is amphoterism. Who knows what ampho means as far as Latin root words go?
Amp
It's
is
like
probably
sound.
water.
Sound and stuff, isn't
Nope, ampho doesn't mean water. Think of amphibian. What do you guys know about amphibian?
And water.
They are on land and water. They're in both. Okay? So in the case of acids and
Always
bases,
going to be neutral.
it's going to be an acid or a base. Okay, so water is amphoteric. Water can act like an acid or a base. Okay, so it's kind of like the amphibian of acid-base species because it can act as both. So if we take water and we add acid to it, so in the presence of an acid, water will act like a base. So an example would be like this. Okay, so if we have acid, hydrochloric acid, plus water, okay, it's going to act like a base. So we're going to be looking at the OH side of this. So what that's going to do is it's going to take and form H3O plus chlorine minus, Cl minus. Basically what this H3O plus means is it's the same as writing H plus, which means it's an acid. Okay. Actually, when you guys take more upper level classes, instead of writing H plus, you guys would be looking at H3O plus. Okay. But that means it's an acid. However, in the presence of a base, what's water going to act like?
Acid.
Water will act like an acid. Okay, so this would be like if we look back up at the pink one, in the presence of an acid, water will act like a base. This is our acid, so that means water is going to be our base. Okay, in this case, in the presence of a base, water will act like an acid. So if we look at NH3, which is, we know ammonia, and we just talked that ammonia is a weak base, plus water. Okay, this is your base. That means this is your acid. You guys are going to form NH4 plus OH minus. Okay. So that's what different types of neutralization reactions would kind of look like. Okay. What about water in and of itself? If water is thrown with water, what is it? It's just water. Okay. the hydrogen and the hydroxide kind of neutralize themselves. Okay, so that's it for you guys' notes. Remember that there's the quiz tomorrow or Thursday. You guys have me tomorrow on molarity and dilution. So if you guys have not watched that video yet and figured out dilutions, you're going to want to do that by tomorrow. Okay, molarity is just molarity is equal to moles divided by liters. Dilutions is where you guys have a concentration and you're diluting it. You're changing the concentration by adding water. And 1V1 equals M2V2. Okay? All right. Oh, this turned off too. I'm guessing I have no sound. I think it all died. Oh, nuts.
God dang it.
Gosh darn days.